So we are going to start up with, I'll just get a textbook. Exercise 3.4. Okay, exercise 3.4. Using elementary transformation. Using elementary transformations. We have to find the inverse. Find the inverse of each of the matrices. Given below. Okay. If it exists. Okay, if it exists. Actually, there should be some small introduction here. I'll come to that later. Okay. Like existence of inverse of a matrix. There should be a little introduction. I will do it later. First, I will show you how to find out the inverse of a given matrix. Okay. In 3.4, there are so many questions. There are 17 questions. Question number 1 to 14 is for 2 cross 2 square matrix. And the question number 15 to 17, the remaining 3 questions, the last 3 questions is 3 cross 3 matrix. So we can find the inverse of a matrix only for a square matrix. Okay, like 2 cross 2, 3 cross 3, 4 cross 4, and so on. Only for square matrices we can find out the inverse. So let's first learn how to find out the inverse of a 2 cross 2 matrix. Okay, so Roman 1 minus 1, 2, 3. This is your given matrix. It's a 2 cross 2 matrix, 2 rows, 2 columns. Yesterday you have learned that. Okay. So using elementary transformation, find the inverse of the matrices if it exists. See, there is a way to determine like whether the inverse of a matrix exists or not. Out of 18 questions, except for one of the question, rest of the matrices the inverse exists. Okay, we will know how. I will tell you that later on. First, let us learn how to find out the inverse of the matrix using elementary transformation. Using elementary transformation means your matrix is made up of certain number of rows and columns. So elementary transformation means you can do some operations along the rows, or you can do some operations along the column. But suppose you are doing row transformation, you are using row operation in the beginning, then you cannot follow up with the column transformation later on. Okay, you need to stick to only one operation. If you have started with row operation, then till you find out the inverse, you have to just keep on with the row transformation. If you have started with the column transformation, then till you find out the inverse of the matrix, you have to just follow up with the column transformation. So the choice is yours. Elementary transformation means using only row transformations or using only column transformation. Is it okay? It's very simple. So what I'm going to do is I'm going to use the row transformation. Okay, using elementary transformations. So I'm going to use row transformations. I'm going to do certain operations on the rows, okay, to find the inverse of the matrix. Let this matrix be represented by A, right? A is like 1, minus 1, 2, and 3. We know that any matrix A multiplied with the identity matrix will give you matrix A itself, right? Multiplicative identity. In number theory also you know that, no? One is the multiplicative identity. Okay? One is the multiplicative identity of any number. Because any number multiplied with 1 gives you the number itself. Okay, so in matrices, this I, for 2 cross 2 matrix, we can write I as 1, 0, 0, and 1. And for 3 cross 3 matrix, the identity matrix will be 1, 0, 0, 0, 1, 0, 0, 0, and so on. Okay? So any matrix multiplied with the identity matrix gives you that matrix itself. Okay? Yes. So here, we know that any matrix multiplied with its identity can give you A, right? Or you can write it this way. Any matrix multiplied with its identity can give you matrix A. You can write in many ways, okay? Now, identity matrix into any matrix will give you that matrix itself. Okay? It depends on in which way you want to write. But I'm writing it this way. Any matrix multiplied with the identity matrix gives you matrix A. Okay? Matrix A with the identity gives you the matrix A. One is considered as the multiplicative identity. And what is the additive identity of a number? Additive identity to Q 0. Additive identity is 0. Okay. Because any number added with 0 gives you that number, right? Yeah. So for a matrix, the additive identity will be the 0 matrix. Okay. Now for a matrix, additive identity will be the 0 matrix, and multiplicative identity will be the identity matrix. Are you getting the difference now? Any matrix added with the 0 matrix will give you this matrix itself, right? So 0 matrix is the additive identity of any matrix, and identity matrix is the multiplicative identity of any matrix. Okay, so that's what I have written here. If you're confused, you can just let me know. All right. This video is not for what to say, merchandise, okay, or various purpose. Okay, it's just for you as a revision. Okay, so your matrix A is 1, -1, 2, 3. We know that I is your identity matrix. 1, 0, 0, 1. Identity matrix means only the diagonal elements will be 1, the rest of the entries will be 0. Okay, into A. You need not write what is A again, because I've already written here. Okay. Now on the left side, we have this matrix A. Your only aim is to convert this matrix to identity matrix. Now as you convert this to identity matrix, using some operations, this identity matrix, whatever operations you do it here, the same operation has to be performed here. So as you do some row transformation or column transformation and convert this to identity matrix, at that time this matrix will no longer be identity matrix. This matrix is going to change. Now this gets converted to identity matrix. This gets converted to another matrix B and A, right? This A as it is. So in that case, what you can do is multiplying or post-multiplying. Post-multiplying, this is higher mathematics a bit. Post-multiplying both sides by A. If I post-multiply both sides by A inverse, then what happens? Let's say that A inverse is the inverse of A. If I post-multiply both sides by A inverse, then what happens? I times A inverse is equal to BA times A inverse. Post-multiply. Right side fale likha do post-multiply. Pre-multiply hula BT iti likhi bole tagi she. Na? Or you can just, you don't mention post multiply, pre multiply, you can just, or if you are confused with this, okay, if this is the first time you are confused, alright, then in that case what you can do is, this is I, right? I can bring this A, transpose this A to the left side. Then it becomes, yeah, 1 by A, or we write A inverse is equal to B, right? So A inverse into identity matrix, inverse only, right? So is equal to B. So this matrix, which has been converted, not this identity matrix, which has been converted to another matrix, say B, becomes the inverse of your given matrix A. Are you following that? You need not write this one. Okay. Yeah. I'll come to this later on, okay, in more detail about the existence of inverse. Are we done? So, again, let me repeat. We know that any matrix means identity matrix into that matrix itself. Same thing. Okay? What I'm writing is A is equal to A only. Because I times identity matrix into A is A only. So what I'm writing is A is A. Okay? Now we have A means 1, minus 1, 2, 3. I is your identity matrix 1, 0, 0, 1, and A. This A you just leave as it is because you have already written what is A here. Now our main aim is convert this particular matrix to identity matrix. Okay, your identity matrix is 1, 0, 0, 1. This is your identity matrix, right? Convert this matrix to identity matrix. But it cannot be done at one time. A certain number of steps has to be followed in order to convert this particular matrix to identity matrix. Okay? What do is, we always start from the last row. Here, we have 0 and 1 as entry in the last row, right? So, the last row has to be converted to 0 and 1. But both of them cannot be done at the same time. Last row de itu entry 0 itu entry 1 hubo lagi to yetibe holibe taijon iki logo na paribo. The first ki kuribo will convert this element to entry 2 as 0. We will convert this entry 2 as 0. We'll convert it to 0. And then we will convert this entry 3 to 1. So the last row will be done. Is it okay? Now, we never start with the first row, okay? We never start with R1, we never start with R2. We always start with the last row. Maybe R3 can be the last row. In this case, R2 is your last row. So the last row R2 has to be converted in this form, 0 and 1 as the entries, okay? But it cannot be done at one go, okay? First, we have to convert this entry, no, to, itu first 0 banabo. Itu 0 banai siya ko ile, itu 1 banabole, it becomes very easy, okay? So, itu kinaka 0 banabo, we have to make use of R1. We have to make use of R1, okay? So in order to make the entries or elements of any row as 0, na, ikta row laga element ikta 0 banabo ko ile, tumikan tay laga adjacent row ki use koro bole lagi. 1 banabo ko ile do, we do not require the adjacent rows. Okay, we don't need the neighboring rows. But in order to make one entry of any row as 0, we need to make use of the neighboring rows. Are you following that? Okay, it can be a bit confusing at first, but if you just keep on doing it, then things becomes easy. So in order to make this entry 0, we have to make use of the neighboring row, which is R1. Okay. So what I'm going to do, how are you going to make this entry 0? What you can do is, you multiply this row by 2. Nah? Multiply this row by 2. And you subtract from this row. Nah? Idu ke 2 bra multiply koribo. Aro, idu logo subtract koribo. To dai 0 jabo no? Nah? Is it okay? Bujase na? Tai kundu roti ase? Tai kundu roti ase? Second row. Tai row 2 di ase do. To second row do transformation jabo ase do change hobo ase do. Tai ki transformation hobo ase ki lago operation use koribo. This row 2 is going to transform. But what operation are you going to use? What operation are you going to use? First, I'm going to multiply row 1 by 2 and subtract from row 2. Is it okay? Yeah. Tai transform korbo lase tai first hobo lagide. Anything that will be done will be from here. Okay? Yeah. So tai 2 bar multiply korigena, you have to subtract from this row R2. So R2 minus 2 R1. This is row 1 diko changes na ibo. No transformation in row 1, right? Now all the elements of row 2 is going to undergo this transformation. So the first element of your row 2 is 2, right? So 2, nah? This 2 minus 2 into what is your R1? 1. Nah? Corresponding to this element R1, we are going to use this element. Corresponding to this element in R1, we are going to use this element, right? Okay. So R2, tumi laga first itu laga koribo de. Ito tumi laga R2 laga element, first element the 2 are same. Minus 2 into R1. R1 ti tayo laga corresponding to ito bodo eh, na? 2 minus 2 to kiman hobo? 0. Tayo 0 shida. 0 ba ni dish? Ha? Aro? Iti ado? Taibi changes anibodo idu operation follow koribo lagi do taibi na? Taibi to operation follow koribo do. To R2 laga next element do kya ase? 3 na? R2 laga itu hoise do. Ite R2 laga itu koribo le ase do e, na? Idu operation do sub elements of R2 ke hi koribo lagi de. No. To ita do R2 laga next element do 3 minus 2 into R1. Tai laga corresponding R1 to kiman ase? Minus 1 ase do. Tai laga corresponding element R1 de na? Minus 1. So 3 minus into minus plus 2 kiman hobo? 5. Into 5 ho jaish. Is it okay? So it can be converted to 1 now. What you can do? Since this is already 0, so what I'm going to do is I'm going to divide this row by 5. So 0 by 5 will still be 0. 5 by 5 will be 1. So R2 will be fulfilled. Is it okay? But wait, not now. So yediki transformation jaishe, same transformation itibi ani bole lagi using the same operation. So sabi no, row 1 di ko changes no koribo na, no transformation in R1, right? Only for R2, right? To row 1 laga elements to inaga rakhibo. Itia, each elements of row 2 will undergo transformation using this operation. The first element of R2 is 0. Here R2 na, the first element of R2 is 0. Minus 2 into corresponding to this R2, what is your R1? 2 into R1, what is your R1? 1. Right? So that's 0 minus 2 is minus 2. 2 iti minus 2 amigo. Itia the next element of R2 is 1. Next element of R2 is 1. So R2, so 1 minus 2R1. 2 into corresponding to this element R1 will be 0 now. So 1 minus 2 into 0, 0, so 1. So this is remains as 1 and are you following that? No? Itiado, ito 0 baneshe using the neighboring row. Tai laga upper wala hodai row ke cholabo. Na? To ida ki kuribo? Ito ke 1 banabo lage do ido. Ito ke 1 banabo le do 1 banabo le nimiti. We do not require the neighboring rows. We can just divide by any scalar, multiply by any scalar. But you cannot add or subtract with any scalar, okay? So what we can do is, this element is present in R2, right? So what kind of transformation will R2 undergo in order to convert this entry as 1? Yeah, divide. Means I'm going to divide R2 by 5. So R2 is going to undergo this transformation. So this will become, this is 1 minus 1 as it is, okay? This will become 0 upon 5, 0, 5 upon 5, 1. No? Same operation has to be performed on the right side. All the entries of R2 will undergo this operation. So 1, 0, minus 2 by 5 and 1 by 5 with A. Is it okay? Itu be hoishe, this itu do 1. Tiki as it? Itu nasawo, itu do last year. First 0 is sawo lagi. To R2 do hoishe do na, R2 do sub condition fulfill hoishe. R1 de, itu 1 hobo lagi, itu 0 hobo lagi. Itu 1 hobo lagi, 1 hi ase. Itu 0 hobo lagi. Itu 1 hoili be last is sawo. Last day. Tai konda boz ase. Itu hi sawo. Itu ke 0 banabo first. Okay? 0 banaboli nimida mekhan ki kore neighboring row ke lobo do ina no hai to tai ke 0 ki naga banabo. What can you say about it? Tai ke 0 ki na banabo, simply R2 logo et kori dibo dai na. So R1 is going to undergo transformation using operation. What kind of operation? For R1 you simply add R1 and R2 na. Then, actually, after every transformation, you have to write like this. Means, itu transformation of PhD, this is equivalent to this. Okay? Equal to no chalabi implies no chalabi. Equivalent symbol chalabi, no? So, every element of R1 is going to undergo this transformation. The first element of R1 is 1. So, R1 plus its corresponding element in R2. 1 plus 0, 1. And then minus 1 plus 1, 0. And then 0. So this has been converted to identity matrix. Same operation on the right side. Same operation on the right side. 1 plus minus 2 by 5. 1 is 1 plus minus 2 by 5. That is 1 minus 2 by 5. Yeah, 3 by 5. So 3 by 5, and then 0 plus 1 by 5, 1 by 5, and then we have here minus 2 by 5 and 1 by 5 times A, right? So this is now your identity matrix, which is equal to, this is any matrix here. Let me write B. And if you do not want B, if you don't like B, then 3 by 5, 1 by 5, minus 2 by 5, 1 by 5 with A. So A can be transposed to the left side as A inverse. So this is 3 by 5, 1 by 5, minus 2 by 5 and 1 by 5. Identity into A inverse will be A inverse is equal to 3 by 5. So your A inverse exists. Okay? And this is the inverse of your matrix A. Now sometimes when you do this operation, when do you do operation on this matrix A, sometimes all the elements of one row, or maybe on 2 or more than that rows, now, if all the entries of one row or more than one row become 0, in that case, it can never be equal to your identity matrix, right? No. Identity matrix is sub entries to 0 ki debi no hobo. Diagonal elements to 1 thakibo. That means every row do ikta element do non-zero hobo lagi na along the diagonal. So whenever you see that every entry of one row or more than one row are all zeros, then in that case no further operations can be performed. So your inverse of that particular matrix will not exist. That is one way to determine whether a matrix inverse of a matrix exists or not. Okay. While doing transformation, if you observe that all the entries of one row or more than one row are all zero, then in that case the inverse of that particular matrix does not exist. Is it okay? Yeah. So you can proceed. I'll show you one more. Okay. Once you're done with the, you can try 1, 2, okay, and I can help you with 4. Number 4.